Good evening, everyone. How is it going? So it's reInvent day 1. We are ahead of a full week of announcements, of talks, and hopefully in this session I'm going to showcase some kind of different usage for existing AWS services. Just a quick question. How many data scientists do we have in the room? OK, quite a few. I don't want to disappoint you, but I'm not showing any Jupyter Notebook in this session. So sorry about that. But bear with me, and we'll try to understand how we can leverage existing and managed services in order to achieve different results and to implement different insight extraction from, apart from their purpose. First of all, I am Luca Bianchi. I am Chief Technology Officer at Inference and Chief Technology Officer at Inference Health, which is our spin-off in the health domain. And the reason of today's talk came from the work that we have done into democratizing the access to AI for health. And I am AWS serverless hero and passionate about serverless and machine learning. And also, I'm from Italy, and I love the opera and Puccini. So if you want to sing with me tonight, please reach out, and we can tweet about that. But this is not the topic of the talk that we are going to have today. Just quick notes. I'm not a doctor. The things that we are going to see today are something that have proven to be useful, and we are trying to to state them as medical devices. But they are not medical suggestions. They are not medical devices. So don't take me for granted. If you want to trade it on your own, but stay with your doctor and follow your doctor advice. Today, we are going to discuss about why health and healthcare is broken, and the age of connected devices, and how to manage time series data collected from these devices. Then what means Amazon Lookout for equipment and what could be used in this domain, which is something quite different from the domain, and then a serverless architecture to handle health data. Just to clarify, I need to introduce a few concepts about healthcare and why we are doing this. So we are not going to see any code for the next, say, 10 minutes, but I can assure that we will see the code right after. Then, first of all, health is broken, and people health is broken, which means that people health is worsening. Considering the data and looking at the data, even before the pandemics in 2019, we had worrisome data. This is a study from US CDC, and a lot of diseases related to people are spreading in the United States and worldwide. I came from Italy. The situation in Europe is not far from the situation in the United States. And the data tells us that between 2010 and 2019, the development of metabolic diseases rose of a worrisome 35%. And this is something that cannot be handled by any healthcare system, because healthcare systems are not taught to handle massive and population-wide health situations. And this was the data before the pandemic. With the pandemic, the data even got worse, because a lot of screening programs have been suspended to help people overcome COVID-19, which means that a lot of diagnoses haven't been done in the last 3 years. That's a huge problem that we want to address. And also, the situation is even worse, because the problem is that a lot of conditions that are not illnesses, but are conditions that can bring people to illnesses, such as metabolic diseases, correlated conditions, that are conditions that can lead people to diabetes, to the development of diabetes. They are not the condition on its own. They have not been treated for many years. They needed a specific screening program, and all the screening programs have been suspended. And when a healthcare system is focusing on keeping people alive, on saving people's lives in the next few months, they cannot afford to screen population to prevent them from developing diseases within 10 or 15 years. But resolving metabolic diseases could improve people's life expectancy and people's life quality, and could even prevent the development of diabetes, of strokes, heart failures, and so on and so forth. But screening, even in this domain, is costly, and it has been disrupted. And we know for certain, because the data tightly correlates within the information that we have, that screening could prevent the development of metabolic syndrome or COPD. COPD is one of the topmost signals that can lead people to heart failures. If you can detect COPD, and you can detect that with just measuring blood oxygen levels across the night, you could treat COPD and you could prevent people from developing heart issues. But none of this is to be done right now because of the situation above. And metabolic syndrome is not an illness. It's not something that you have to worry in the near future. A lot of people have metabolic syndrome. I have metabolic syndrome. It is a situation related to heart rate variability, body weight, blood pressure, body response to glucose, that try to enforce themselves and try to prevent people from improving their signals, their metrics. But this is not a condition. People feel well. They don't have health issues. But this is the reason why this condition can be often undetected for many, many years, because you don't have any problem. But it is tightly related to diabetes and heart failures. Because if you do not treat metabolic syndrome, if you do not reverse this pattern, you could probably say for 70 to 80% for sure develop diabetes or heart failures within 20 years, and so on. But what to do? I told you that we can detect and prevent these illnesses using screening programs, but I also have to tell that screening program has been disrupted. But luckily to us, from every crisis came opportunities, and we are living the age of connected devices. So we are living in a period where we have easy and affordable devices at our fingertips. First of all, it is the continuous glucose monitoring system, or GCM. GCM are smart sensors. They are simple to use and to remove. They are simple to apply, and they have been developed for patients with diabetes, but they can be used by any kind of people, just to understand how their body is responding to glucose level. And they can measure fasting glucose, so the level of glucose that you have when you get up in the morning. But also the insulin response of your body to food intake, or the glucose response to hydrations, which are really interesting metrics to be monitored, because they tell you how well your body is behaving when you are consuming sugar, when you are consuming carbohydrates. And GCM devices are easy to be used, are affordable devices, and Peter Attia, which is one of the world's topmost experts in longevity hacking, stated that everyone should wear a GCM device at least once in their lives. It sounds weird, but it is not at all, because wearing a GCM device for a couple of weeks can give you a lot of information, a lot of data about your health status, about the problem that you could develop in the future. And it's something that you have to take account of. But this is the kind of data that you can have when you wear a GCM device. And on the left side of the screen, it is the data that I have collected across many months using the standard measurement method, which is the needle that you use to cut your finger and you take a blood samples. It's quite invasive. It's not the best thing that you can do. And in the right side of the screen, you can see the huge amount of data you can collect just wearing a GCM device for 20 hours a day for a couple of days. So it is much better, a lot more data. But if you collect all of them, you could have problem because the data set could be not so good for machine learning because you could have a change of frequency of the data sampled within your data set. It is something that you need to take into account when you develop a method, a model to analyze that data. And another thing that you can discover using real-world data, real-world glucose data, is that you can have missing data. You can have gaps within your data. You can have gaps because the sensor often broken when you hit a corner or when you try to remove the sensor, and so you lose the data. Maybe you lose a few hours or a few days of the data if you are waiting for the replacement. But you can also have missing data because maybe you don't want to wear the sensor all the year long. And you have to take that into account. But glucose patterns are something that could be useful to extract insight about your health. This is a chart about how the data can be plotted to showcase the patterns, especially my patterns. And you can also see that the sampling of the sensor occurs multiple times per hour. The sampling rate should be every 10 minutes. And this means that you have a lot of data, and you can also plot all the curve, the responding curve to food intake. Why to monitor glucose? Because glucose response is coupled to patterns in glucose behavior. The glucose value is not relevant. You could measure the glucose value every day, and it is not significant except you have diabetes. If you don't have diabetes, it is not relevant. But knowing the pattern and how glucose levels change over time could be really interesting. And because impaired glucose response is not a medical condition, but it is related to diabetes development. If for many years you have impaired glucose response, which means that when you get up in the morning, your glucose level are higher than, say, than 100 grams per milliliter, you could, it's not for sure, but you could develop diabetes later when you grow older. And GCM devices provide a clear understanding of body response to glucose. And they are super helpful because you could also avoid outliers. I've discovered on my own that if I measure the glucose as soon as I get up in the morning, as soon as I pull my feet out of the bed, I have higher values than if I measure the same glucose level, say, 5 minutes later. So having something, continuously measuring the glucose, could allow you to avoid such kind of bias. But corrected data we've seen that could present gaps or changes in frequency. It's not the only data that we have at our disposal. We could also use blood pressure monitoring devices. It is non-invasive, it is simple to use and very cheap. And it is a smart sensor. Today, almost every blood pressure monitor you can buy on Amazon. It is a smart device that can sync with your smartphone. It gives you data about systolic and diastolic blood pressure and heart rate. Heart rate is relevant to measure how it changes over time. And it allows the detection of hypertension or better heart rate variability. It's quite easy. This is the kind of data that you can achieve in real use cases. It is my data, and you can see that you can have a change of frequency. And the reason is quite funny that change of frequency it is in the spring of 2020, and it was related to the fact that I got worried about COVID, and I started measuring every 3 to 4 times a day my pressure to be sure that everything was fine. But the truth is that your data won't be perfectly sampled as in test data, as in standard machine learning data set that you could use. So you have to take into account also the fact that the sampling rate is not the same for all the data. And also the fact that you could have outliers in your data, because maybe you have not worked correctly the device, you have not used correctly the device, and the measurement is not good. This is the reason why you could have outliers. You have to detect them and remove them. And then after that, also, considering heart rate, you could collect heart rate data from a number of devices, such as blood pressure monitoring or smartwatches like this one, but the frequency of the data, the collected data changes over time. It is interesting being able to collect and analyze heart rate because it also gives you some kind of insights about the stress level. If you could measure my heart rate right now while I'm on stage talking to you, maybe it will give you some insight about my stress level. And all this data is filled into Apple Health or Google Fit apps within your smartphone. So you just only have to pull that data out from your devices and start analyzing them. Within Apple Health or Google Fit, you have many metrics. In the case of Apple Health data, you have an XML which more than 30 different features measured over time. The export could be quite big. In my case, I've been collecting data since 2012, and in my case, it is 1.5 gigabytes. And if you can consider that the most part of the data is related to the last 2 years. So could be big. And I've seen that there is also a lot of redundancy in the data, within the data that you have to consider. So you need to pre-process and filter the data in order to build the standard CSV file that every data scientist loves to have at his fingertips. But our idea, my idea was to use AI to monitor health patterns. It's nothing new. A lot of people are doing this right today. But I found some kind of problems that needed to be addressed. The first one is related to data conversion. So you collect data from XML file, from Apple Health Kit, and then you need to parse them and convert them. The other problem is, the second one is a bit trickier because you need to have some kind of domain knowledge in order to remove unwanted values, such as glucose values below 50 milligrams, which are not meaningful, because if you have glucose levels under that threshold, probably you are dead, so it's not meaningful at all. And then you need to repack the data in order to build a time series data set. And this is all the tasks that you need to achieve even before start developing your machine learning model, start thinking about the kind of model that you want to use. You need to repack the data and to upload the data to an external data storage such as Amazon S3. But time series data presents some issues that we have seen before. There could be a lot of null values because you could choose a sampling rate which is too high for the kind of data that you have. And you could have sampling differences between one sample and another, one portion of your data and another. You could also have unbalanced data set. Because just in my case, I had a lot more data related to the last few years compared to, say, 2012 to 2018. Then, considering health data, you need to focus on the whole patient, not just only on one metric. Considering just blood pressure is not relevant to understand whether or not a person is in good health or has the risk of development of metabolic illnesses. And here is where Amazon Lookout for Equipment comes into the play. Because Amazon Lookout for Equipment, how many of you knows what Amazon Lookout for Equipment is? Okay. So just let me show you. Amazon Lookout for Equipment is a service that has been released, if I'm pretty sure, in 2020, and it is a service taught for industrial data monitoring. The idea of Amazon Lookout for Equipment is to monitor the behavior on industrial equipment. You have an industrial machinery, you can monitor pressure, flow data, voltage, power supply, vibrations, and so on and so forth. And you could collect that data and fill that data into Amazon Lookout for Equipment. And Amazon Lookout for Equipment is going to tell you to build a model and to train a machine learning model on your behalf and also fine-tune that model. And then it can also handle data from up to 300 sensors. So you can have a lot of different metrics for your equipment and fill that data into the service. And it performs anomaly detection. So it can tell you whether or not your industrial equipment is going to break or is going to have issues. One thing that is important is that this kind of inference is asynchronously performed with Lookout for Equipment. So the data is stored on S3, it is processed from S3. There is no direct connection with existing sensors or existing devices. And the most important part is that no prior data science knowledge is required to be used. You just only need to call the right API and fill the data into the system, then call the train primitive, the train method, and then obtain the model and start performing inference. And one thing that I like most about Lookout for Equipment is the fact that it performs multivariate data inference, which means that it tracks patterns not only on a single time series data, which is pretty easy to do. It can be tricky, but it's pretty easy to do. It tracks patterns across different metrics, different time series at all. And it is the thing that could be really helpful in our case. One question that I often get asked when I talk to my colleagues about this approach is, why not use Amazon Lookout for Metrics? The main reason is that Amazon Lookout for Metrics is a great anomaly detection service, but it only works on a given specific time series per time, which means that you cannot perform multivariate analysis with that. So the idea was to use Amazon Lookout for Equipment and apply that to health. And map sensor domains terms to metrics and assets to people, and fill the data related to glucose, to blood pressure, to blood oxygen levels, to heart rate into a Lookout for Equipment, train the model, and use that model to predict anomalies and to extract insights about people's health. And datasets can be pulled from commercial devices. Then the model can be trained, can be fine-tuned, and can be deployed in a managed way with no machine learning knowledge required. And it is useful because that model is a digital twin of the person, is a digital twin of yourself, is a digital twin of a patient, and it is able to detect health anomalies. Health anomalies are not meaningful for health diseases, but can be insightful to detect them. So you can have health anomalies if you, usually don't go out for a run and then you got for a fitness session. So it could lead to an anomaly. But if you stack a lot of anomalies, this could be helpful in tracking health issues. And then we need to build a server architecture around that for data ingestion and anomaly notification. Parsing Apple Health data and converting that to a pandas suitable format is not an easy task. It just could be worrisome. Basically, you need to convert the data into numbers because the data export are basically strings. Then remove null values and sanitize matrix names because it is too verbose. But it is not too difficult. It's something that you have to consider. You can have some kind of pitfalls or problems, but it's something easily achievable. And also parsing GCM data when you collect data from different devices, such as blood glucose monitor, and the glucose monitor that I've used do not export data into into Apple Health Kit, which means that you have to collect the data to export the data directly from their specific app, and then you need to combine different historical historical trails of data. In this case, there were two different histories, two different data sets. The first one was related to automatic sampling, and the second one was related to manually triggered sampling. And we need to merge them into one single data and to adjust timestamps in order to have one single data set. Then once if you have prepared your data and you have uploaded your data to S3, you can use the dataset schema discovery feature of Amazon Lookout for Equipment. This is a super cool feature available within the console, and it means that you do not have to specify the schema of your data. The service is going to detect the data schema for you. It's going to understand which metrics you have within your data. But if you want to fine-tune that schema, if you want to have complete control on that data, you can specify using the Bot3 SDK. You can specify the schema structure, and you can prefer a coding approach rather than a console approach. Once that you have defined your schema, you can instantiate the Lookout for Equipment client, and then you can use create the dataset function in order to create a dataset belonging that schema. We are not ingesting the data right now. We are just creating a placeholder for the data. After that, we can move on to data ingestion. That ingestion can be done through the console, and you can just select the S3 bucket containing the data and tick on the usage of CloudWatch. And then after that, you can select a schema detection method to use schema discovery. After this step, the data ingestion fires, and within a couple of minutes, your data is ingested into the service, and it is encoded and prepared to be used for model training. You can achieve the same result with code, just using the Lookout for Equipment client, and then looping to wait when it's completed. One thing that Lookout for Equipment gives you for free is feedbacks about data ingestion quality. Data quality is the topmost priority if you are going to build a machine learning model because your data set is the foundation of your model. So if your data is bad, probably your model won't perform correctly. And Lookout for Equipment gives you some kind of insights about the data that you filled into the model. You need to consider a few constraints. The first thing is that the minimum amount of data that you need to provide is 90 days in order to have a reliable model. The second one is that having too many gaps within the data could worsen the analysis because it introduces a knob value bias. So the model, if it has many gaps, it faces many gaps, the models is not sure whether these gaps mean that you have no data or the data was null in that day. And the missing data points are forward filled by Lookout for Equipment. This is super cool because if you prefer a Jupyter Notebook approach and you start coding your model on your own, you need to address the sampling issues, the sampling problem. But Lookout for Equipment does this for you and forward fills missing data points. But you should aim for having to have no more than 10% of missing values because otherwise it is going to worsen the quality of the outcome model. Then duplicated data is omitted, so you don't need to filter out duplicated data. You don't need to remove that. Considering that we are hacking Lookout for Equipment to be used with health data, I have not been able to achieve more than medium quality sensor grade. But medium is more than enough to train a model. Training a model means that Lookup for Equipment is using an unsupervised anomaly detection model to build your model. And it involves hyperparameters auto-optimization in order to find the right models on your behalf. You don't even know the kind of model that it is going to use. You don't even know if it is going to use a Poisson model or maybe a neural network or an LSTM or whatsoever. It is going to auto-tune the model and to select the right model for your data, so the most performing model. But please consider that the dataset is encoded within the service. So different datasets means different models, which means that you update massively. So if you massively update your dataset, you probably need to retrain the model. Then you have the option to fill labels, to provide labels about your data. So you have the option to say, OK, from day 1 to day 11, I was traveling. From day 2 to day 4, I was doing fitness sessions, and so on and so forth. And labels force Lookup for Equipment to use neural networks because they provide ground truth for the neural network. Then I managed to train a model for each different patient. And training is super easy within the console because just to adjust, you have just to provide the split of the dataset between training and evaluation. And dataset can be used entirely, but I do not suggest to do this because you won't have the evaluation feedback on the model, which is important if you want to know whether or not your model is behaving correctly. Then data sampling should be set to the highest data frequency and let Lookup for Equipment manage all the subsampling issues. Then missing data are estimating during training to fill the gaps. After this, you could provide labels. So you could say, OK, this was a fitness session, a party, or a trip. And labels allowed the model to draw subgroups on your dataset and to optimize the model within each subgroup. You can also train the model using code. So you can just import you can just build the create model request, which the same parameters, and then call create model function on Lookup for Equipment client. Then you have to wait until it completes. Within the console, it is going to provide you training results. So it is going to analyze the data and provide anomaly detection on the evaluation set of your data set, which is interesting to understand whether or not your data is behaving correctly. Events are identified, and also the metrics that contributed to that anomaly event are outlined. It is interesting because it does not only tells you, OK, you have an anomaly on day 2 or day 14, but it also gives you feedback about the metrics that contributed to that anomaly. Then few detected events could be irrelevant and could not be tied to changes in health status, but a huge number of anomalies could definitely lead to the detection of health problems. Labels are helpful to detect anomalies. In this case, the anomalies was related to a fitness session. Because I went out for a run, I was wearing my glucose device, and it produced an anomaly. Then inference can be built directly from the console, and it is performed using a batch behavior, which means that inference data is uploaded to S3, and then from S3 data is collected, analyzed, and anomalies are pushed back to S3. Data structure must be similar to the structure of the data that you have provided to train the model. Be careful about that, because if you change the structure of the data, if you change the name of the metrics, if you do not provide the same structure within your data, probably the inference is not going to perform. It is going to give you errors. So you need to stick to the same dataset schema. And anomalies are saved into the destination bucket as JSON lines, so they are easily to be used, easily to be analyzed for further inside extractions. So it is super easy because you just need to hit the inference button within the console, or use the start inference primitive within the client, and it builds an inference detector for you. Please consider that inference is a running task within Lookout for Equipment, which means that you are paying for that service being run from time to time. So if you don't need that anymore, you should stop the inference explicitly. Then putting all together, we need to build a serverless architecture around that in order to have a suitable service. And this is the reason why I decided to use Amazon IoT and IoT topics in order to expose one topic for each metric that I wanted to monitor, which is super easy because Amazon IoT topics are MQTT topics, so you can push the data and streamline the data into your system just using Amazon IoT topics, and then you can filter that data and filter that topics using IoT rules. IoT rules allow you to dark the data to a Kinesis data file rows stream, which you can set up using either managed data file rows or a serverless Kinesis data stream in front of the data file rows. So you can decide whether or not you want data to be pushed directly to data file rows, or maybe you need a Kinesis data stream before data file rows in order to further transform the data. Then data file rows dumps the data to S3 and saves the data to S3. You can also define a Lambda function to customize the data, to further transform the data if you need to start managing, if you need to start transforming the data before saving the data into an S3 bucket. Then from S3, you can use a Lambda function to clean the data, to transform the data into the data set that we need to be provided to Lookout for Equipment, and then we prepare the data and save the data back to S3. And after this, Lookout for Equipment is invoked in order to analyze the data. So the data is filled continuously to Lookout for Equipment. Lookout for Equipment is going to pull the data from a specific S3 bucket, and you need to provide the bucket key where your data relies. And it analyzes the whole data belonging to that bucket, and detects anomalies and saves anomalies back to S3. After this, you can fire even breach events whenever anomalies occurred. Wrapping up all the things that we have seen today, we can consider that we have a lot of data coming from personal devices. So we have a lot of data that we can use, we can monitor, and we can use to build a digital twin of our health, ourselves. Then we have seen that time series is the most typical type of data. Most of the data that you have that these devices are going to collect are time series data. And multivariate time analysis is required to process this data. Just in this simple case, I've used multivariate analysis to process glucose, blood pressure, heart rate variability. Then we can collect insights from real-life behavior and track them down to the system. You can also build, say, a smartphone app for that and have your patient track whether or not they are doing something different from the usual. Then after this, we could use this system to detect condition far before health issues arise. And we are experiencing a lot of interesting anomalies, say anomalies between quotes, being detected in order to understand whether or not people are changing their lifestyle. Because if you change your lifestyle, it will be tracked as an anomaly by the system. And we could also try to extend this to a cohort, to a group of patients, to monitor health lifestyles of a group of people. And another thing that we could do is to fill the data into Amazon Forecast to predict how a single metric is going to behave in the near future, and then send these predictions back to Amazon Lookout for Equipment in order to detect anomalies. So we could also build a more complex system able to forecast anomalies in the future. And so that's all for today. I want to thank you for your time, and we have time for questions, and I will be around the venues. Thank you all.